Take a second and just feel the ground beneath you. It feels solid, right? Unmoving, like the most reliable thing in the entire world. But sometimes that reliability just vanishes. Maybe you remember seeing the devastating pictures from places like Haiti or China. We all remember those terrible moments when entire cities were destroyed, literally from one second to the next. These are some of the most common, and certainly the most horrifying, natural disasters we face. And here's the question that keeps coming up. Are earthquakes happening more often now? It feels that way, doesn't it? Every time we switch on the news, there's another report, another tragedy. Is the Earth getting angrier? Is the planet simply more active? Or is something else going on? Today, we're going to look past the headlines and uncover the truth. We'll find out that the answer is actually split in two. One part is a natural, ancient rhythm, and the other part is a surprising and worrying result of human activity. So, why does the Earth quake at all? To understand this, we have to look deep inside. Imagine the entire planet, not as a perfect sphere, but as a gigantic, fiery jigsaw puzzle. The outer shell, where we live, the crust, is broken up into about 7 large pieces and many smaller ones. Scientists call these the tectonic plates. Think of them like colossal sheets of ice floating on water. Why are they moving? Because right beneath that thin crust, which, by the way, is only about 1% of the Earth's total mass, and is sometimes as thin as an apple skin compared to the other layers, is the mantle. This mantle is hot, thick, and partially molten. Due to convection currents inside, these plates are continuously drifting. Here's the wild part. They are moving right now, even while you watch this. They move slowly, maybe just 1 to 10 centimeters each year, literally a few inches. You won't feel that movement day to day, thankfully. But the problem arises when these pieces meet. They interact in 3 ways. They pull apart, they slide past each other, or they smash into each other and collide. When these giant pieces of rock grind together, they create enormous pressure. Think of trying to push 2 sandpaper-covered bricks past each other. The friction is immense. This friction builds up energy over years, decades, or even centuries, like winding a huge spring. When the rock just can't take the stress anymore, that tension is released in one massive, sudden jolt. That is the energy release that generates seismic waves, causing the surface to shake. We have special names for the places where this happens. The point underneath the Earth where the energy is first released is the hypocenter, and the spot directly above it, on the surface where the worst damage typically occurs, is the epicenter. We measure these events using a tool called a seismograph or seismometer. This device helps us assign a level on the Richter scale, usually running from 0 to 10. Anything around magnitude 5 can start damaging buildings, and anything above 7 is considered a major earthquake. We have seen terrifying power unleashed. Imagine a magnitude 9.5 earthquake that happened in Valdivia, Chile in 1960, or the 2011 event in Tohoku, Japan, a magnitude 9.0, which tragically took nearly 16,000 lives. Now, back to our main question. Why does it seem like they are increasing? When we see these recent devastating events, like those magnitude 7+ quakes in places like Haiti, Chile, or China, it certainly feels like the frequency is spiking. But here is the amazing truth, backed up by long-term records going all the way back to about 1900. The rate of major earthquakes, magnitude 7 or greater, has stayed relatively constant. On average, we expect about 16 major earthquakes globally every year. The number does jump around a bit. It's what scientists call a quasi-random process. For example, 2010 had 23 major earthquakes, which felt like a lot, but 1989 only had 6. We notice those clusters, but we quickly forget the quiet periods in between. So, if the big ones aren't increasing, what is happening? The massive increase in the recorded number is an illusion created by technology. We are simply better at listening now. We have seen a huge increase in the number of seismograph stations worldwide. The National Earthquake Information Center now locates about 20,000 earthquakes around the globe each year. That's about 55 every single day. The recorded increase in catalogs like ComCat is not because the Earth is shaking more often. It's because we have more instruments capable of recording more quakes. Most tremors happen several thousand times a day, but are so weak you can only detect them with a seismograph. Think of it like this. The Earth has a steady heartbeat, but we've gone from listening with our ear pressed to the chest to using a high-tech stethoscope. We are simply detecting all the tiny little murmurs we missed before. Plus, thanks to global communication, we learn about these events instantly, making us more aware than ever. So, the natural rhythm of major earthquakes is steady. That's good news, right? Well, hold on. There is a deeply serious and worrying twist to this story. While natural quakes follow the laws of physics, recent studies suggest that human activity is now directly influencing the timing and frequency of other earthquakes. This isn't about the small, human-induced quakes we already knew about, the ones caused by things like water injection, extraction, drilling, or mining. This is bigger. Groundbreaking research from experts like those at the GFZ German Research Center for Geosciences and the University of Southern California points to a shocking conclusion. Man-made climate change will lead to more, and possibly stronger, earthquakes worldwide. How on earth can global warming shake the deep crust of the Earth? It comes down to two major forces: accelerated melting of land ice, especially in Greenland and Antarctica, and the rising global sea level. Let's look at the numbers for a second. Between 1901 and 1990, the sea level rose about 1.4 millimeters per year. Recently, between 2006 and 2015, that rate jumped to 3.6 millimeters per year. By 2100, sea levels could rise between 0.43 and 0.84 meters. Imagine a giant, critically stressed underwater sponge. If you constantly pour water on it, you increase the pressure. This rising water increases the hydrostatic pressure on the tectonic faults sitting in the underground. This pressure is small, but it's significant. Professor Marco Bonhoff, a lead author of the study, explains that sea level fluctuations of even just a few decimeters, that's just inches, are enough to trigger quakes. This is a massive revelation. Why? Because many faults globally are already critically stressed, meaning they are close to the end of their seismic cycle. They are wound up and ready to snap. That small extra pressure from rising seas is enough to activate them ahead of time. We are literally advancing the Earth's natural seismic clock. Where is this human-induced risk worst? You guessed it, coastal regions. Around 40% of the world's population lives near the coast. These areas often host crucial fault zones, including subduction zones where one plate slides under another. Think about rapidly growing megacities like Istanbul, San Francisco, Los Angeles, and Tokyo, Yokohama. When climate change pushes a quake in these areas, the danger explodes. Dr. Patricia Martinez-Garzon, a co-author of the study, points out that these quakes create terrifying cascading effects like landslides, tsunamis, and the liquefaction of soft soils. We are making our homes more vulnerable, just as we are making the planet more restless. This increased seismic risk reinforces an urgent need. We must fight global warming, but we also must change how we build our cities and develop our risk mitigation plans. We know we cannot predict a major earthquake with certainty, but our ingenuity is working overtime. Remember I mentioned the seismograph? Well, now even our smartphones can detect seismic waves, giving scientists real-time data to warn people. And get this, scientists have found that just before an earthquake, regions record high concentrations of radioactive gases like radon and thoron. These gases leak out from tiny cracks right before the main shock. If we can reliably detect these gases, we might be able to predict a quake up to 7 days in advance. Imagine the safety that 7 days could give us. The story of why earthquakes are happening more often is deeply human. On one hand, the natural, massive tremors are steady. We are just better equipped to hear the 20,000 tiny quakes that happen every year. On the other hand, we now face a terrifying new layer of risk, a seismic shift triggered by our own hands. We are loading the dice, forcing the Earth's natural stresses to break sooner. The growing risk from human-induced climate change is a stark reminder. We must reduce global temperature rise. We must invest in better monitoring and build smarter, more resilient infrastructure, especially in those vulnerable coastal megacities. We must consider the full climate impact, including the secondary dangers like liquefaction and tsunamis. The Earth moves to its own ancient clock, but now we have the power and the responsibility to choose whether we push that clock forward into chaos or invest in resilience and hope for the future.